In this video, I will be introducing how to identify and model quadratic functions. The standard form of a quadratic function is in the form of ax squared plus bx plus c. Now please note that a cannot equal 0, and the reason for that is that if you multiply 0 times a variable, you are going to get 0, which means it will leave you with just a linear equation of bx plus c. So in order for it to be a quadratic, you must have a variable squared, and that is considered the quadratic term right here. It is the term that has the variable that is squared. The linear term is the variable that has only an exponent of 1, which we call the linear term, and then a constant does not have a variable, it is just a number. So for example, if we had 2x squared plus 3x plus 7. 2x squared would be considered a quadratic term, 3x would be considered our linear, and 7 would be considered our constant. Or if we had 3x squared minus 8, this would be represented by our quadratic. We would not have a linear term because there is no just single variable. And then negative 8 would be considered our constant term. So we do not always have to have all three terms for it to be a quadratic, but we must have the square in order for it to be a quadratic function. Now, graphing a quadratic function x squared is in the shape of a parabola, or you could say a U shape, where the vertex of a quadratic is going to be either the lowest or minimum value of the graph, or it is going to be the highest or what we call the maximum value of a graph. If x squared is positive, then the vertex will be the minimum value, and it will go in both directions on either side. If x is negative, then the vertex becomes the maximum value, and all other terms will be below it. Now we have two things called vertex and axis of symmetry. The vertex is your lowest or highest point, which is what we just discussed, and the axis of symmetry is a line, normally a vertical line, that divides a parabola into two equal parts. Now, I say almost always a vertical because there could be a situation to where a parabola could be graphed sideways, in which case the axis of symmetry would be horizontal. But in terms of functions, the line is going to be a vertical line. So in this case, we have a parabola that is this function. The vertex will be the lowest point of the parabola, so the vertex would be the point 2, 3. The axis of symmetry is going to be this vertical line, and all vertical lines are represented by x equals, always. The vertical line is x equals, and it is going to be represented by your x value of the vertex. So because the vertex is 2, 3, then the axis of symmetry is going to be x equals 2. It, again, always, in this case of a function, will always be the x value. So let's identify the vertex and axis of symmetry. So in this case, we are looking for the highest or lowest point. So in this case, we're looking for the lowest point, and this is the point -2, 1. So therefore, my vertex is going to be the point -2, 1, and my axis of symmetry is going to be x equals, because it is always, if it's a function, it was going to be a vertical line that goes through the vertex, and so it's going to be x equals, and you're looking for the x value, so it's going to be x equals -2. So I'd like for you to pause the video, attempt to find the vertex and axis of symmetry, and then press play to see the answer. Okay, the vertex of this point is either going to be your highest or lowest, which in this case is now going to be the highest point of the graph, and it is the point 2, 0, and the axis of symmetry is going to be a vertical line that goes through the vertex. So I know that the vertex is going to be the point 2, 0, and the axis of symmetry is going to be x equals, again, because it's a vertical line, and you're looking at the x value of the vertex, so it will be x equals 2. Now, a real-world connection of where we could use this. Jane throws a ball up in the air, and the graph shows the height of the ball in meters after t seconds. Now, so normally when we're dealing with a graph, we are normally dealing with an x-axis and a y-axis. But because this is a real-world situation, it is not necessarily going to be x and y. So you got to think of the horizontal axis and the vertical axis. So where this is normally your x-axis, in this case, it is dealing with time. Your horizontal numbers is dealing with time. So this is 0.5 seconds, 1 second, 1.5 seconds, 2 seconds, and so forth. The vertical axis, which we're normally used to seeing as a y-axis, in this case is height in meters. This is telling how high a value is going. So this would be represented by 1 meter, 2 meters, 2.5 meters, 4 meters, 5 meters. So the first thing is they want to know what is the vertex of the parabola. So they're looking for the highest and lowest point, which in this case is going to be your highest point. And so it is the number 1, or the coordinate point, 1, 4.9. But now they want to basically an explanation of what does that mean. And so how many seconds, they're looking for seconds, have gone by at its highest point. Because it said highest point, we're dealing with the vertex. But you got to determine, what do these values represent? The first value, 1, represents the horizontal axis, which we said was time. So this is representing the number of seconds. And the second number is dealing with your y value, which in this case is height. So this is dealing with meters. So they want to know at the highest point, at the vertex, how many seconds have gone by. And so we're looking at how many seconds. So the answer is going to be 1 second has gone by. Next, what is the max height? So now they're wanting to know height. In part B, they want to know seconds. Now they want to know height. So we're now looking at the y value, which in this case is height, which is meters. So 4.9 meters high was what the ball reached. And last, how many seconds does the ball hit the ground? So when you're thinking of hitting the ground, that means you're not in the air at all. You're literally at 0 meters. You're at the ground. So you're looking for when the meters, the height is 0. So you're now looking for that point. And the second value we know is in meters. And the first value we know is in seconds. So in order to find out how many seconds, we're looking for this coordinate point, which is 2 seconds. So in our second real-world connection, I would like for you to pause the video, attempt each of these parts, and then resume play in order to see the answer. Okay, Stella launches a toy rocket from a platform. The graph then shows the height of the rocket in feet after seconds. So again, when we're dealing with the x-axis and the y-axis, we're not dealing necessarily with x and y. We're now dealing with time, and we're dealing with height, which in this case is feet. So the first thing is they want to know, what is the vertex? Again, they're looking for the highest and lowest point. So the highest point is 3.25 and 441. Next, actually does not have to deal with the vertex. They want to know how high the platform she stands on. So if you look back at the explanation, it says that at the very beginning, when time is 0, at the very, very beginning, before it all starts, it says that she launches from a platform. So at 0 seconds, we want to know how high is she, and she is 272 feet high. So she is standing on a platform that is 272 feet in the air. Now it says after how many seconds, so we're looking for the x value, seconds, does the rocket reach its highest point? highest point is now again dealing with the vertex. So go to the vertex, and they want to know how many seconds it took to get there. So don't forget the x value, the horizontal value, is dealing with seconds. And the second value, or the y value in this case, is dealing with height, which is feet. And they want to know how many seconds did it happen, and it happened at 3.25 seconds. And then they want to know how high did that rocket go. So you're looking for the highest value of the entire graph, and it is 441 feet. And then last, how many seconds? So again, we're dealing with the x value. Did it hit the ground? Okay, again, hitting the ground is when it's not in the air at all. It is literally at the ground. So we want to know, when is it at 0 feet? So we're now looking for, again, the seconds when it is 0 feet, and it is at 8.5 seconds.